next up, we have Stephanie Green for a double feature. She'll be giving the next feature. Hang in.
Good afternoon, everyone. It's a pleasure to be with you today and to have our program all happening at once. This presentation was originally going to be given by my graduate student, Aneri. Unfortunately, she couldn't attend Reef Futures this week, and so you get to hear from me instead. I'm also giving the next talk after this, which is my talk, so you get a double feature from me. We are based at the University of Alberta in Canada, but we work in South Florida and the Caribbean region for about the last 15 years. And I must confess, I am actually one of those fish people that has come to restoration. Looking at those reciprocal interactions is what we do in our lab. And so Aneri's work was looking at disentangling reef fish settlement cues and the extent to which how and where we restore corals influences those cues and the patterns that we see. So what Aneri was primarily interested in and what we work on in our lab is the relationship between habitat structure and composition, and then the reciprocal nature of that relationship in terms of the services that fishes provide back to those foundational species. And in the context of thinking about how fish find and use corals as habitats, Aneri sort of came up with a framework for evaluating that process. And really what we think about is both the attraction of organisms like fish to habitats like corals, and then the resources that they find there that might retain them to those sites. So we think about both the amount of habitat that's there, but also the relative quality, which might be, for example, the proportion of live coral tissue versus dead skeleton or artificial substrate that we find there. And so Aneri's work was really trying to disentangle the quality and the quantity of reef that is there for fish to recruit to in the context of coral restoration. In particular, there's a few things that she was looking at. She wanted to know how the environmental structure of the reef framework that already exists at reef restoration sites might influence this process of recruitment, as well as the quality of the corals that we're putting back. So she had three sort of key research questions, which I'll address in this talk. The first of which was just background without restoration. How does reefscape structural complexity affect fish recruitment and retention to reefs? So how many baby fish are coming to and staying on reefs, even if we're not doing restoration there, as a bit of a benchmark. And then does that background structural complexity affect the way that coral outplanting might influence fish recruitment and retention to those sites? And then a third component, which involves some new methodology, was trying to disentangle the role of structure versus things like cues, chemosensory cues that come from adding live coral tissue. So does the proportion of live coral added to a reef affect fish recruitment and retention in combination with that background structural complexity? So to get at this third objective required a lot of method sleuthing on Aneri's part with a number of collaborators. She did a lot of looking back in the literature to think about how she was going to create corals that would structurally mimic as close as possible in terms of fine detail the habitat attributes that baby fish might like. So she looked back into the literature, was looking at different options for constructing artificial reefs, 3D printing, and the materials that she would use. And she decided that really what she needed to do was develop her own method so that she had a very explicit recipe for how she would create realistic modules that she could then share with others who might be wanting to do this kind of habitat selection work. So she had three criteria. She wanted it to be accessible in terms of the resources needed, scalable, and also as ecologically realistic as possible. So she evaluated all the existing methods and then looked to a combination of 3D scanning, printing, molding, and casting to develop her own technique, essentially working with engineers, sculpture artists, and paleontologists, which it turns out we have many at the University of Alberta, to combine these techniques to get the best of all of the different worlds, to come up with a scanned and printed replica here of a Acropora cervicornis that had a high level of detail, to then create molds that she could then cast and assemble units from to be ecologically realistic. If you want to know more information about the very nitty-gritty details of that method, it's captured here in this paper that we just published in Frontiers in the Built Environment, the marine section of that. So once she had this method worked out, we wanted to look at these 3 research objectives in the field. And we did this at a reef that is just offshore here from where we are at Reef Futures, Careysport Reef here in Florida. And this reef provides a wonderful study site to test those questions about background structural complexity effects on fish recruitment, because you can choose plots that differ in the background structural relief, both on the reef flat and then sort of the high spur and groove environment. So what Aneri did was, working very closely with partners at the Coral Restoration Foundation who are already outplanting Alcropora cervicornis at this site, she set up 4 plots, 2 of high background structural complexity and 2 of low. And she essentially designed an outplanting experiment that manipulated where and in what proportion these live coral outplants were put in relation to her artificial mimics. So these are just some videos of what those outplanted, we call them sort of microhabitats, look like. So each cluster of corals varied in the proportion of live coral fragments to artificial, going from 0% live cover to 100%. And then we had control plots where there were no corals outplanted of any kind. And each of those plots had 10 corals. We then monitored very closely those corals over time once they were outplanted. Lots of fun, sometimes murky underwater activities going on at these sites, and measured a bunch of different response metrics. So here what I'm showing you on the x-axis of this plot is the time of the experiment. And Aneri tried to estimate recruitment as the initial density of fish that came to each of the plots, as well as the recruit density that persisted over the course of the experiment, new fish coming in. She also looked at the density of fish that were of larger size classes at the end of the experiment to approximate retention. And then she also looked at just the overall density of all fishes that were of a larger size class across the course of the experiment. So multiple metrics looking at both that recruitment phase of small juvenile fishes and then retention of slightly large size classes. And I should say this is for all species in the community. So what did she find? So just to take you through what's the effect of reefscape structural complexity, these are what the results plots are going to look like. On the y-axis here, we have our different metrics that we measured. So recruitment rate, density of small recruits, and then the density and richness of larger bodied fishes throughout the course of the experiment, so mimicking the attraction and retention phase of habitat use. And this is just looking at plots that didn't have any added structure to them, so background recruitment. What we find is that we see, depending on the metric, either that recruitment or retention is similar in terms of, for example, species richness, or just initial recruitment rate between low and high complexity areas on the reef. But that recruit density over the course of that experiment and the final density of those larger size classes of fish is higher in high complexity areas. This might not be surprising. There's probably more structure there to support those fishes. But it provides us a background to then look at the effect of adding structure and adding coral through restoration. So to get at our second question, does reefscape structural complexity mediate the effects of coral outplanting on fish recruitment and retention? This is what the results look like. So just to orient you here on the plot, on the x-axis here, we've got percent living coral in 2 treatments. So in the low complexity reefs and the high complexity reefs. And then on the y-axis, we've got each of our metrics of response. And what was really interesting to observe is that habitat patches had a greater effect in low structural areas. Again, perhaps not surprising, but adding coral, regardless of whether it was 100% live coral added or a mixture, or even just adding structure, was more impactful on the reef flat than it was in areas of high complexity. So how does the proportion of live coral added back to the reef matter? Or do fish just care about structure, which is something in our coral restoration efforts that we all really like to think, no, they don't care if it's just structure, they really want the coral, right? We saw some really interesting results. And in particular, across treatments, in terms of the background low or high structural complexity reefscapes or the measurement that we took, we saw this really interesting nonlinear response in that we had high rates of either species richness or density or recruitment, both at plots where we just added structure, so no live coral, and at plots where we added really high proportions of live coral, but consistently low responses in mixed plots where we had sort of intermediate proportions of live and artificial outplants. We're still teasing apart what's going on here. When we look at it on a species by species basis, we see that it appears to be that it's different types of species responding to the treatments. So for example, some taxa do seem to just care about structure. Some are incredibly associated with the corals. And when you look at the community as a whole, you get this really mixed response. So it suggests that species-specific monitoring of recruitment will be important in order to be able to establish whole community response. So the implications of this, the benefits of outplanting for recruitment and retention, at least initially, seem to be greatest at low complexity portions of the reef. And so if we're looking to measure just the initial response, we might want to either account for or consider the background complexity of the reefs that we're outplanting in when we're comparing across plots or across sites. And some species appear to be more sensitive to the addition of live coral cover or simply adding structure. And stay tuned for a publication led by Aneri coming out on this, and hopefully can give another update at the next Reef Futures. Thank you very much to the many partners that made this possible, and thanks for listening.
We have time for questions.
So how long was the experiment? Because the corals kind of grow, as we all know.
Yeah.
So like, do you guys put out bigger pieces once the other live pieces of coral started growing, or do you leave the tiny pieces still there?
Yeah, and I did not mention that. I think Aneri would be mad that I didn't. So this experiment happened between mid-June and mid-August. So 2 months of coral growth is what we would have seen. There were a little bit of differences by the end of the experiment, but they weren't substantial throughout most of the trajectory of it. So we're measuring over about an 8-week period when fish recruitment, in the summer when fish recruitment tends to be highest in that region.
And the percentage of, I think, live coral versus just the structure was just measured 2D.
The percentage